All right, guys, we're going to be taking a look today at the last section of notes, actually, in Chapter 5, Section 5.8, and it's polynomial models in the real world. Really what we're looking at is how can I take some data that we've collected and find an equation that matches this, so then I can use that equation to maybe predict some things that are going to happen. All right. So I want to start off with just a real quick review of how to enter this stuff into your calculator, and how to make a scatter plot and a regression line. We did this back, if you remember, we did this back with our starburst experiment. All right, where we measured people's hands and saw how many starbursts they could grab. So just real quick reminder of how to enter this data in here. Okay. So let me get set up here. All right. So if I've got my calculator, all right. So the first thing I need to do is enter this data into my calculator. So I'm going to hit Stat, and then Edit is already highlighted. And so I can hit 1, or I can just hit Enter, and that takes me to my lists. Now I've already got some information in my list. I want to get that information out of there. So I scroll over until L1. My list 1 is highlighted, and I hit Clear and then hit Enter, and it'll erase all that. And then I scroll over and up until L2 is highlighted, and hit Clear and hit Enter, and it'll clear that whole list out. That way those two lists are completely empty for you. So what I'm going to be doing is I'm going to be putting X. I'm going to put these numbers in my list 1 and these numbers in my list 2. All right. So that is 0, 5, 10, 15, and 20. All right. And now I go over to list 2, and I want to put in 10.1, 2.8, 8.1, 16, and 17.8. So I've got that information listed. Now to make a scatter plot, which is what we're asked to do next, so you go up to Stat Plot, which is in blue here. So I want to hit Second Stat Plot. And mine's kind of already set up. Like I said, I've done this a couple of times already, but you just want to make sure that this is on. And again, it's already on 1. I'm going to go ahead and hit equals to get into that menu here. So make sure your plot 1 is on. The type that we're looking for is a scatter plot, and that's already highlighted here. My X list is list 1. My Y list is list 2. And you can choose whatever mark you want to use here. I'm going to just stick with those squares. Now, before I graph this, just to make sure my window is set up right, I'm going to hit Zoom, and then I'm going to scroll down. I think it's number 9. Yeah, number 9 is Zoom Stat, and that'll set that window for you, in comparison to the data that you entered. All right, so there's my scatter plot for these 5 points that I put in here. Okay. So now the next thing we're asked to do, all right, we've entered the data, we've made a scatter plot, and now we want to do a linear regression, okay, which we want to find a line that matches that data, okay. So let's go back to this, all right, and again, we did this with the starburst one, so hopefully this will seem familiar once we get it. So to do my linear regression, I'm going to hit Stat, and then I'm going to go over to Calculate. And number 4 is linear regression. So I can either type in 4, or I'm just going to go down to 4 and hit equals. And my X list is list 1. My Y list is list 2. You don't need to worry about frequency. I'm just hitting enter as I go through here. Now here's the one thing you want to store this equation that we're going to come up with. You want to put it into that Y1 so it graphs it. So here's what I'm going to hit. I'm going to hit once I have my cursor here at store regression equation. I need to tell it where to store it. So I'm going to hit variables, and then I'm going to go over to Y variables and hit enter because I'm on function, which is what I want. And I just want to put that in Y1. I could put it wherever I wanted, but I'm just going to put it in Y1. I hit enter again, and I go ahead and hit enter one more time, and it calculates it for me. It's got the slope here. It's got the y-intercept. We'll talk later about what this r squared and r means, maybe on another day. But now if I go ahead and hit graph, again, you can hit Zoom 9 again, but that window's already set up for us, so it should, okay, draw that line. Now, it says how well does that fit, okay? Yeah, really not real strong there. Okay, now so we've done that before, but now what we're going to look at today is we can do other types of equations. Instead of straight lines, we can do quadratics. We can do equations that involve x squared. Maybe that'll fit it better. Or cubics, equations that involve x cubed. Let's take a look at both of those and see if they fit a little bit better, because that's okay, but I think we can do better. All right, so again, I'm going to go to Stat and go over to Calculate. And now you notice number 5 is a quadratic regression. All right, so I'm going to go down to 5, not 6, but 5, just making sure you're paying attention. And again, everything's the same here. And now I want to replace that line with the quadratic line that it's going to come up with. So I've got that blinking right where I want it to. So I hit variables, go over to Y variables, hit enter, and then now let's put this equation in Y1. Okay, so this is telling me what my equation is going to look like. And now if I hit graph, I get a parabola. That's what kind of at least the part of a parabola there. And that really doesn't seem to fit it much better. Okay, so now let's look at a cubic. All right. So again, I'm going to hit Stat, and I'm going to go over to Calculate, and you notice number 6 is a cubic regression. So let's go down to cubic. You can either type in 6 or scroll down and hit enter on 6. And again, I want to do the same thing. Main thing you want to remember is to store that regression equation in Y1. All right, and again, to do that, I hit variables, go over to my Y variables, hit function, and hit Y1. All right, and then just make sure you hit calculate as well. Otherwise, it's going to keep that quadratic equation in there. And now if we graph it, let's see if this one fits any better. So here is a cubic equation. Oh my, and that fits a heck of a lot better. Okay, so what we're looking at today is not only making a scatter plot with data, but now instead of just looking at a linear regression where we get that line of best fit, maybe it's more of a curve. All right, maybe it's a quadratic, maybe it's a cubic. All right, that's kind of what we're looking at today. All right, so how do we decide which one to use? Okay, well, to do that, we use what's called the n+1 point principle. Okay, basically what that says, it says for any set of n+1 points in the coordinate plane that pass the vertical line test, so again, this has to be a function, there's always a unique polynomial of degree n that will fit those points perfectly. So what does that mean? What this means is if I have 2 points, there is a linear equation that will exactly go through those 2 points. If you give me 2 points, as long as they pass the vertical line test, which means as long as those 2 points aren't right above each other, I can come up with a linear function, a y equals mx plus b function that will exactly fit those. If there's 3 points, then it will be a quadratic function, all right, an x squared function. And you see where this n+1 comes from. X squared, this is a second degree function, all right, 2 plus 1 gives me 3, all right. If I've got 4 points, all right, similar to, never mind, we had 5 points there, scratch that. But if I've got 4 points, that means that there is a cubic function, okay, or an x cubed function that will fit those points perfectly. All right. So if we let's take a look here. How do we apply this? So it says what polynomial function has a graph that passes through these 4 points? Okay. Well, if there are 4 points, then I'm looking for a cubic function. There is a cubic function, a cubic equation that will exactly go through those 4 points. All right, and that's what I'm looking for. Okay, so let's see if we can do this. So the first thing I want to do, all right, is I want to put these now into my list. Okay, so I'm going to hit Stat, and I'm going to go to Edit because I want to put new lists in here. I want to clear out that information that I just put in there. So I go up to L1 and hit Clear. I go over to L2 and hit Clear just to get that information out of there. And now again, I'm going to put my X values in my list 1 list, and then I'm going to put my Y values in my list 2. All right. So here we go. So that would be 0, 1. Again, I'm looking at my X values. 2 in each of those ordered pairs, and -1. And now I'm going to put my Y values in. That would be -3. Again, make sure as you're doing this make sure you're using the negative button, okay, not the subtraction button. Okay, so to do -3, make sure you're using that negative button. Okay, so -3, -1, 5, and -7. Okay. Now, again, if I want to just look at this scatter plot again, before I just hit graph, I want to, because I've got a new set of data in here, I want to hit zoom, and I'm going to go down to number 9 there. All right, and there's those ordered pairs I just put in. Okay, and whoops, and it's actually also graph in the last graph we had there. So let me get that out of there. If I hit y equals, you see that's that cubic graph we had from our last one. I can just hit clear. It wasn't a big deal, but might bother some of you. So there we go. There's those 4 ordered pairs, and actually it looks like a linear. Probably might be a linear one that fits it kind of closely, but we can find a cubic that fits it exactly. So let's do that. So I'm going to hit stat, go over to calculate, and then we had said we want a cubic equation. We want to do a cubic regression. So you can either type in 6 or just hit 6. And again, list 1, list 2, that should be pretty standard. Frequency, you don't need to worry about. Just you want to make sure you store this every time, okay? So variables, y variables, function, and let's put this in y1. And then the other thing you got to make sure you do that I forget to do sometimes is make sure you calculate it, get it back to this screen, okay? So now what that's telling me, because what it was asking for is, all right, give me the function, all right? So we know it's a cubic function. We know it's y equals, and the calculator is even telling you this. It's ax cubed plus bx squared plus cx plus d, but they are telling you what a, b, c, and d are, all right? And r squared, we might as well talk about this right now. That r squared being 1 means this is a perfect fit. Okay, the closer r squared gets to 1 it kind of gives us an indication of how closely this is matching it. But the function that we want to use is I'm just filling those in there. Okay, let me fill those in here. So it'd be 1x cubed minus 1x squared, because my b is -1, plus 2x plus -3, or you could just put -3. Again, all I did was just take these values for A, B, C, and D and put them in the appropriate places there, okay? But now if you want to look at this graph, okay, there it is. All right, there's that cubic function, and it fits it perfectly. And if you forget to write it down before, now that we've stored it, you can just hit y equals, and there it is. You can see 1x cubed plus -1x squared. I'm just scrolling over here. Plus 2x plus -3. Okay, so that's the cubic function that exactly fits those points. All right, we're not going to do this one. This one would be a similar process. All right, if you want to do that one on your own, you're more than welcome to. Okay. All right, so now let's look at maybe some real life data here, and just a couple other things that you need to kind of think about. So here's a chart that shows how much milk is made in Wisconsin dairy farms. All right, so I want to let's find now we're going to find a linear model. But again, the first thing I want to do is get this information in my list. So I'm going to hit stat, and I'm going to hit edit. I'm going to clear everything out of those lists. That way I'm starting from scratch. Okay, get everything out of list 2, so you're starting from scratch. Okay, and I'm actually just going to enter these dates in here. I tried this, and this actually worked pretty well. So here's my X list, and here's my X and my Y, list 1, list 2. So I'm just going to put those in there. 1955, 1980, 2005, and then I'm going to go over and put in the Y values here, list 2, which is the milk produced in billions of pounds. So 16.5 billion pounds of milk, and then 22.4, and then finally 22.9. Okay. All right, now it says what linear model best fits this data. Let's go ahead and do a linear regression right now. So again, I'm going to hit stat, go over to calculate, and they asked us for a linear regression. So let's do number 4. I'm just going to hit 4, list 1, list 2, and I'm going to store this thing. So variables, y variables, you guys are going to be experts in this by the time this gets done here, okay? And then I'm going to calculate it, and there's my linear, there's my slope and my y-intercept, and notice our r squared, pretty good value there, pretty close to 1. Now, Let me just look here real quick. Now, again, before I just hit graph, because I've changed my information, I want to go to Zoom. Should remember this by now. I think it's Zoom 9. Okay, yep, that'll fit our window to exactly fit. All right, so we see this linear model. There's the linear model that represents this data. Now, so the question then is, well, now it says use the model to estimate what it'll be in 2020. Okay, so now that I've got this linear model, here's the nice thing about a linear model: I can kind of estimate. So again, I want to say, hey, where will this thing be in 2020? Now I'm going to do this wrong first, but I'm going to show you why it's wrong. So we can actually do that. So we've got this calculate menu. So if I hit second and trace, that's my calculate menu, and I want to find an exact value, and I want to know what will Y be when X is 2020, because X was my years. And if I hit enter now, it says, wait a minute, there's something wrong. And that's because, I'm going to quit. That's because if I look at my graph doesn't go up to 2020. Okay, so I need to fix that. It won't find a value if it falls off your graph here. So I'm going to go up to my window, and you notice my X max here only goes up to 2010. So I'm going to go up, and I always like to go just a little bit past it. I'm going to go to 2030. Okay, and now I look at my graph. It should look just a little bit different because we've added some space off here to the right. But now if I want to say, hey, what will this be in 2020? So I go to second calc, and I want to find a value in 2020. Now it tells me that Y would be about 25.72. That if this trend continues, it'd be about 25.72 billion pounds here. All right. So what was that? 25.72. Okay. Billion pounds, because that's what our our chart was in. Okay, now let's just answer this question here, because some of you might have been asking this, some of you might not care. But I'm going to answer it anyway. Why do we use a linear model when a quadratic will fit it perfectly? All right, if I've got 3 points, we just saw that if you've got 3 points, there's a quadratic one that'll fit it perfectly. I mean, ours isn't bad. It's not bad, but we can find a quadratic that'll fit it perfectly. So why did we do linear? Let's look at this. All right, so now I'm going to do a linear regression. So stat, calculate, and I'm not a linear, I'm going to do a quadratic. So down at number 5, I'm just going to hit the number 5. And again, list 1, list 2, store it in Y1. So variables, Y variables, function Y1, and then calculate it for me. And again, I don't need to reset the window here because we've already got it set where we want. So now if I graph this, here's the quadratic, here's the parabola that fits that perfectly. So why didn't we use that? What problem do you see? Well, this kind of assumes that, wait a minute, is milk production going to, for some reason, decrease here? No, probably not. Probably milk production is probably going to continue to increase, all right? I mean, there's more demand for it, more people. So, there's nothing that says this milk production, will start to decrease. So sometimes, and we'll talk, you'll have to look at this, that even though you've got this principle that says, hey, if you want to find one that fits it exactly, here it is. Sometimes that's not real life. Okay, so you do kind of have to analyze that just a little bit. Okay, all right. So let's finish this up here. So here's this table shows how much cheese people eat. All right. So from 1910 to 2001. So let's go ahead and get that information in there. So I'm going to hit stat and edit, and I want to clear out my 2 lists that are in there. So L1 clear and L2 clear. Okay, and I'm going to put this information in there. There's list 1 and there's list 2. All right, so let me do that here. Let me go over to list 1, and that's 1910, 1940, 1970, 1975, 1995, and then 2001. Okay, and then I'm going to go over and put in my pounds consumed per person. All right, 4, 5, 8, 10, 25, and 30. Holy cow, we are a fat people. All right, so yeah, in 2001, the average person ate 30 pounds of cheese per year. Holy cow. All right. Now, it does say model this with a cubic function. All right, let's go ahead and do that. All right, stat and edit. Nope, that's not what I want to do. Let's try it again. Stat, and I'm sorry, let's go over to calculate. And cubic is down there at number 6. So I'm just going to type in the number 6, L1, L2. Let's store it. So variables, y variables, y1, and go ahead and calculate that bad boy for me. Okay, and there it is. And notice it doesn't do too bad. Oh, it does a really nice job of fitting this thing. Okay, so there's my graph. Oops. Oh, good. You know, I did not make a mistake there. I did this on purpose. Why doesn't that look good? We forgot to reset our window. All right, so anytime you enter new information, you got to go to Zoom and then all the way down to number 9, or I'm just going to type in 9, that Zoom stat, and it'll kind of fit the information for you. Okay, so there's this cubic function that models the consumption of cheese. Okay, and now we can start estimating, hey, what would this thing be in 1980? All right, so we're looking at, hey, 1980. What will it be in 2000? And what will it be? What was it last year? What was it in 2020? What is it this year? All right. So once we got this in there, it's just second trace, calculate a value. And I want to know what it will be in 1980. Whoops, I said 1900. Let me try again here. Oh, no, that's 1980. 1980 looks like it's about 12.6. So 1980 was about 12.6. And you notice it does actually show you right where it is. It'd be about right there on your graph. Okay. What was it in 2000? All right. So second trace, calculate the value when x is 2000. And it'd be about 29.4. Okay. And now in 2020, all right, now wait a minute, well, let's do this, all right, yeah, 2020, second trace, find the value at 2020. Oh, shoot, our window's not big enough. So let's go back to window. Oops, first I got to hit quit. Let's go to our window, and our window only goes up to 2010. So again, I'm going to go, instead of 2020, I'm going to go up to 2030. I always like to go a little bit past it, okay? And now I should be able to graph it. It'll take just a minute for it to redraw that line since we've done that window. And now second trace. Hey, what was this thing in 2020? Okay, and it's about, holy cow, about 60.8 pounds per person. Okay, so now we've answered that question, but take a look here. It says, in which of these estimates do you have the most? Which of these seem right to you? And hopefully it's these first two. Okay, because we could see them right on the graph. All right, but this one I kind of question. Are people today eating 60.8? Is this graph going to keep on going like that, or is it going to start to curve or bend again? Okay, and so I'm not saying this isn't right, but man, I just can't be sure about that. And that all has to do with these two things. All right, what we're trying to do here is called extrapolation. Okay, and that is predicting outside the domain. When we extrapolate, we're going outside the domain. Now remember, domain is your choices for x, and our x values only goes up to 2001. And we were looking at, hey, what's going to happen in 2020? We're looking outside of our domain, past our domain. And that can sometimes be a little bit tricky. Okay. Do we know if this data is going to continue the way it has been? Okay. Whereas interpolation, okay, is predicting inside the domain. And so for example, in these two were examples of interpolation, because 1980, that's right in here. Okay, I'm pretty confident there that if it was 10 here and 25 there, yeah, about 12.6 sounds about right. 2000, yeah, that's interpolation because it's inside the domain. This is we've got a little more confidence in that. Okay, so you just have to be careful when you are doing these predictions of predicting with stuff outside the domain, because we don't know what that day is going to do after 2001. Is it going to continue up, or is there going to be another bend to it where maybe another function would be good? Okay. All right. Now, as far as your homework goes, I have changed it a little bit. I don't want you to do 17, 18, 19, or 22 or 23. Okay. I have cut that back a little bit. So I want you to do 8, 11, and 15. And then on 21, they're going to give you some information here. And I think 21 actually refers back to question 17. That's where you're going to have to look at for your table. Okay. But they're going to give you a table, and they're not going to tell you what kind of function. I want you to do linear, cubic, quadratic, and see which one you think fits the best, and then answer that question on 21 using what you think there. All right. So take the next couple days to get these finished up. I'll have the answers posted shortly. And if you have any questions, let me know. All right. Have a good weekend, guys. Take care, and we will talk to you later.